Morning dear students, welcome to the e-learning class. So how are you? I hope you all are good and your study is going also good. Okay, so today we are going to discuss about a chapter, and this is a chapter which you have already learned, because you learned about the some uh, right angle triangle, about the right angle triangle, and in that right angle triangle you learned about some special words, okay, like hypotenuse and then perpendicular, then we also known about the trigonometric ratios. Okay, so what are the uses of that trigonometric ratios in our daily life? Huh? Because if we are learning something, so it should be useful to us. Okay, so today we will learn that how this trigonometry or trigonometric ratios benefits us in our daily life. Okay, so let's start. Okay students, so now it's welcome, this chapter welcomes you. Okay, now look at this. Can you figure out which object is this? Okay, I know you all know that it is kind of mountain peak, but which is the highest mountain peak? Okay, it's my question for you. Which is the highest mountain peak in the world? Can you name? Yeah, very good. Keep it up. Okay, so the highest mountain peak of the world is Mount Everest. Okay, and this peak is located in Himalaya. So this is the Mount Everest. The height of the Mount Everest is, okay, now who will measure the height of Mount Everest? Can you tell me? Okay, if I ask that measure the height of yourself, what is the height of your, so you can easily measure yourself by using the meter tape or something like this. But to measure the height of Mount Everest is not easy, because it is too large, too it is too large to measure. So how got we how got we the height of the Mount Everest? So what is the height of Mount Everest? This is the highest mountain peak, and its height is 8,848 meters. Okay, it's too high to measure. We cannot measure it with our daily life tools. Now next, this is the highest waterfall. It's so high that you cannot see its cliff. It's so high. What's name? Can you name the highest waterfall in the world? Okay, so let's see. This waterfall is called Angel Waterfall. Okay, this waterfall is called Angel Waterfall, and its height is 3,230 feet. It's also too high. We cannot measure it with our measuring tape, or we cannot use our ruler to measure this one. So we need something. Now this is another, this is our, yes, tell me. It's our solar system. The distance between the earth and the sun. Now what is the distance between earth and the sun? It's also too big. So this is 150 million kilometers. So these are the some figures which are too big to measure. Okay, we cannot measure it with our usual instruments. So there is a question arises that how did we figure out what are the actual measurement of these figures? Okay, so let's start with a story. It's an ancient time story. I think you all are interested in story. Okay, so let's start. So there is a big kingdom, and in this kingdom there was a king. Now he is the king of Egypt, and he told that the tallest pyramid built so far is the pyramid of Cheops. Now there are some pyramids in the Giza. I think you all heard about the pyramid of Giza. So the tallest pyramid was the pyramid of Cheops. Now this king want to build a pyramid which is taller than the pyramid of Cheops. So how tall is this pyramid? Now he want to build uh, another pyramid which should be taller than the pyramid of Cheops. So now he wanted to know that what what is the height of pyramid. So he asked all his courtsmen, "You are the wisest man in the kingdom. I am sure you will figure out a way to measure the height of the pyramid in 2 days time." Now he gave only 2 days time. So it's very tricky question because they cannot measure two big pyramid in only 2 days. So what they said, yes, it is impossible. How can it be possible to measure the height of pyramid in only 2 days? So it's impossible. Now there is another wise man. I think you heard about the Akbar Birbal story. So he is the Birbal of this kingdom. So he said it's possible and he can measure. So how is this possible? Let's take. So this is the pyramid, and uh, how will he measure this height of this pyramid? So he will use some trick to measure the height of pyramid. So what do you observe? When sun rises from this to position to this position. So did you observe something with its shadow? Its shadow gets decreases. Again, when sun goes to other side, then its shadow also increases. Now his mind bulb ignited to see this. Okay. Now he checked. He got how to measure the height of this pyramid. Okay. First he saw his shadow and he measured its shadow by him. Now look at this. The height of the man is equal to the height of that rod. Now the same height he can measure with his shadow. Yes. So at one point of time his height is equal to the length of his shadow. This is at only one time his height is equal to its shadow. So if he can measure its shadow, so it is equal to its height. So this is how he can measure his height. So now he needs to measure only its length of shadow, and at this time and at the same time he can measure the shadow of this pyramid. Okay, because at this point of time, because when sun has a specific angle of elevation, then the length of shadow is equal to the height of this pyramid. Okay, so he needs to measure only the length of shadow. So this, it is also applies on this pyramid. So that's how he measure the height of the pyramid by using some tricks. Okay, you can also measure the height of trees, height of a building by using this trick also. So today we will learn about this trick. How did he use this trick, and which branch of mathematics he used to solve this problem. So here the height of this pyramid is equal to the length of its shadow, and he can easily measure the length of shadow. and also it makes an angle. You know this angle. So it is a symbol to denote an angle. So this symbol is called, do you know, it is called theta. We can use this symbol so many times. There is one theta, another one is, this is called phi. So we use theta here. So there is an angle theta, and we cannot this problem by using a right angle triangle. So here is a right angle triangle ABC, where which angle is 90 degree? Can you tell me? Yes, very good students. The angle B is 90 degree. Okay. So at one point of time, theta has some specific value. Theta is an angle, so it may be 30, 40, 50, 60 degree. Okay, but at one specific time it has some value. Now look, AB is side of right angle triangle and BC is another side of right angle triangle, and we all know about the trigonometric ratios. So there is a only one specific value of theta for which side AB is equals to side BC. Okay, when the AB is equals to BC, and at which time? Now find the ratio of AB upon BC, and this is called isosceles triangle. Okay, so at this point of time, angle A is equals to angle C. Now we know that in an isosceles triangle, the opposite angles are also equal. So this angle A is equals to angle C. Okay, do you know why both the angles are equal? Because it is an isosceles triangle. Okay, now tell me, what is the sum of interior angles of a triangle? Yes, tell me. Yeah, very good. It is 180 degree. Now sum of the interior angles is 180 degree. So that's how we can find the value of theta. And also angle A plus C should be equals to 90 degree, because third angle is 90 and angle A is equals to C, which is 45 degree. So that's how we can find the value of theta, which is 45 degree. For this value of theta, and a right angle triangle should be a isosceles triangle. Okay, in this triangle AB is equals to BC. Okay, so at angle theta, AB is equals to BC, and if we change the angle of theta, then the ratio of BC and AB, it will be changed. So in this triangle it is called height. So if we have a triangle ABC, so it is called height, and BC is called distance or length of shadow. So this is distance between B and C, and it is an acute angle. And here again theta is changing and also BC is changing. So we can have multiple values of theta, and this is called altitude of the sun, which is 60 degree. It is called altitude or also inclination angle. So when a shadow of a body is made, then this is called altitude of the sun. So there is a relationship between the height, distance and acute angle of a right angle triangle. Now we already studied about the relation between the height, distance and acute angle of a right angle triangle, and we call this one as trigonometric ratios. Okay. So this is about trigonometry, and in this chapter we will learn the applications of trigonometry, how we can apply trigonometry in our daily life. Okay, so you already know trigonometry is made by three words: tri, gono and metri, where tri means 3, gono is called side or angle, okay, and metri to measure. So this is again a right angle triangle. Here, look here, we already know that there is 90° at angle B and the side opposite to 90°, what it is called? Yes, can you tell me? The side opposite to 90° is called? Very good. It is called hypotenuse, and hypotenuse is the largest side in a right angle triangle. Okay, so hypotenuse is fixed and this hypotenuse is always opposite to the right angle, and this is an angle theta, and the side opposite to theta, the side which is opposite to angle theta is called opposite side, or we can say in another term as perpendicular. And the side which lie with theta is called adjacent side, or we can call this one as base. So now we have three sides: opposite side, adjacent side based on angle theta, and hypotenuse based on angle 90°. Okay, and it is again called perpendicular, base and hypotenuse. So we all know about the trigonometric ratios. So opposite upon adjacent equals to tan theta. Then opposite upon hypotenuse is sin theta. Adjacent upon hypotenuse is cos theta. So now what is 1 upon tan theta? Yes, the opposite of tan theta. Yes, tell me. Yes, it is cot theta. So the inverse of tan theta is cot theta, and its value is adjacent upon opposite, the opposite to this one. Again 1 upon sin theta is, yes, tell me students, what is the value of what is the inverse of sin theta? Good, it is cosec theta. And again cos theta inverse is sec theta. So these are 6 trigonometric ratios. We call them trigonometric ratios or T ratio. Okay, and I think you all remembered all these definition of these trigonometric ratios. Okay, so again you have to learn, because now we will use these terms in our next chapter, in this chapter. So we can write in this manner. So there is a trick to learn all these. It is so ka toa, where S means sine and opposite upon hypotenuse. C is cos, then A upon adjacent upon hypotenuse. Then tan is opposite upon adjacent. Okay, now there is a question. In a right angle triangle, side opposite to 90° is called, and your time starts now. So what is the side which is opposite to 90° is called? Yes, tell me students. Give the answer quickly. Your time is getting over. Okay, so time is over. So we already know that this is our right angle triangle. If this is 90 degree, this is angle theta. So this is called hypotenuse, which is opposite to 90 degree. What it is called? Hypotenuse. What side opposite to theta called? Yes, perpendicular. What side with theta called? Base. So these are terms. Correct answer is C. And it is making an angle 60 degree. Now there is a question, find the height of the tower. So this is how we can denote this by this diagram. So there is a right angle triangle ACB where C is 90 degree, angle B is given 60 degree, and BC is 15. We have to find the value of AC. Okay, so in this triangle we will use, look how we can choose the values of the side, how we can choose which side we have to pick. Okay, so let's see here. First, what we have to find? Yes, we have to find AC upon, now what is given to us? BC. So we have to find the ratio of AC and BC. Okay, what we have to find? A ratio of AC and BC. Now look at this triangle. This is called opposite side because it is opposite to 60 degree. This is called adjacent side. So this is opposite upon adjacent, and this ratio is equals to, yes. So what will we use here? Yeah, exactly. We will use tan theta here. And what is value of theta? It is 60 degree. Okay, so we can write this one as AC upon 15 equals to tan 60 degree. Now I think you already know what is the value of tan 60. So who will tell me the value of 160? What is the value of tan 60 degree? Yes, tell me students. Yeah, very good. So you are very correct. The value of tan 60 degree is root 3. Now put the value. Okay, so this is the table of ratios. So in this table all the 6 ratios are given and the value up to 90 is given. Okay. Okay, now what is the value of tan 60 degree? It is root 3. So here we have two angles, 30 degree and 60 degree. And tan 30 is 1 upon root 3 and tan 60 is root 3. Okay, now there is another trick how to learn all these values. So write angles in your fingers. Okay, it is 0, 30, 45, 60 and 90 degree. So that's we can find the value. So this is called cos. If you goes from 0 to 90 then it is cos, and if you come back so it is sine. Now root of all the value, divide by 2. So each your finger denotes the value. It is 0, it is 1, it is 2, it is 3, it is 4. Okay, so if we have to find the value of 30 degree, so it is called 1, Then find the root of 1 and divide it by 2. Okay, for 0 degree we have 4 values. So divide 0 by 2, it is 0. So value of sin theta is 0. And for cos we have, how many fingers we have? Yes, we have 4 fingers. So find the root of 4 and divide by 2. Now for 30 degree, how many fingers we have? Yes, for sine we have 1, 2, 3. So it is root 2. And again for cos we have root 3 by 2. Now what is the value for 45 degree? At what point it is? Yes, it is denotes by 2. So find the root of 2 divided by 2. For sine you have to count from this side 0, 1, 2, 3 and 4. Okay, so value of, so this is how you can find the value of sine and cos here. Okay class, now it's question time. So use your raft and give the answer. The reciprocal of tan theta is, and your time starts now. What is the reciprocal of tan theta? Sin theta, B sec theta, C cot theta and D cosec theta. Okay class, your time is over. So reciprocal of tan theta is, yes, you are correct, it is cot theta. So value is C. Okay, so I think you understood about what are the T ratios of angle theta. So we have 6 T ratios. Now what are complementary angles? So do you have any idea about the complementary angles? Yes, tell me. What angles are called complementary? Yes, very good. Okay, so the sum of two angle is 90 degrees, so both are called complementary angles. So if one angle is 30 degree, then its complementary is 60. So both 30 and 60 are called complementary angles. So here we will use the complementary of this one. So we have sine 90 minus theta is called cos theta. So these are complementary angles, which is sine and cosine, tan and cot, sec and cosec. Okay, because these can be changed into one another. So we can write this one as sine 90 minus theta is equals to cos theta. Then again we have cos 90 minus theta is equals to sine theta. So it is applied to all these. Now again we got the value of AC. So here we will use AC upon BC equals to tan 60 degree. Now what is the value of tan 60? Yes, it is root 3. Okay, so from here you can find the value of root 3, or the value of AC is 15 root 3. So this is the height of tower. Now find the height of this building. So it's too tall to measure. So he will use here. So what he will use? He will use the application of trigonometry here to find the height of this building. Yes. So his eye is making an angle with the top of this building. Okay. So if we can measure, or we can connect this this line to this one, so we get the value of theta. So this is observer's eye, if anyone is observing, and this is object. It is called line of sight. An imaginary line connecting the object to the observer's eye is called line of sight. Then this is again imaginary line which is parallel to the ground. It is called horizontal line. Again an imaginary line which is parallel to ground, and this is called angle of elevation. Now look at this angle of elevation. If we look any object which is higher than us, okay, so the angle made by the top and the eyes is called angle of elevation. If the object is above the observer's eye level, the angle between line of sight and the observer's horizontal line is called angle of elevation. So now we have the diagram of the right angle triangle. Now we can measure the height of any object, any building, any tower. Here again we can see this is observer. Now she wants to find the width of river, and she goes up in the stairs, and now she is above the object which she has to measure, and this is observer's horizontal. It is horizontal line. Now this is line of sight, which is down to earth, and this is called angle of depression. Okay, so if the object is below the observer's eye level, the angle between the sight and the observer's horizontal line is called, what it is called? Yes, it is called angle of depression. So now you have two kind of angle of elevation and angle of depression. Okay, now there is an instrument, it is called inclinometer. So there is an instrument, it is called inclinometer, and inclinometer used to measure the inclination angle. What it is used? Inclination angle. So here you can also make the inclinometer. So on a piece of cartridge sheet, play your protector and draw a semicircle. Divide the portion of the semicircle on either side of 0 into 10 equal parts, starting from 0, then 10, 20, 30. So you can measure as your protector has. Now color the half part as red and half part as blue. Remove the protector and mark the angles as shown. Color the two halves as red and blue, and also cut this extra part. Now you have a big protector made of paper. Fix a drinking straw along the base of semicircle with sellotape as shown. Mark the point O just as the center. Also mark E and D, 2 points. Now fix the wooden strip on the piece of plywood to shown to make a stand. So this is a stand, and here you can fix this one. Now fix the wooden strip on the piece of plywood as shown to make a stand. Now fix the instrument which we had prepared earlier to stand by hammering a nail. You have to fix it by hammering a nail. Now it will move like this, it will hanging like this. Observe an object above the eye level using inclinometer as shown, and you can observe any object from this place because it is hollow and you can see from the hole of this straw. So here you can use the inclinometer to measure the inclination angle. Okay, so this angle is called inclination angle. Here it will show what is the inclination angle. So this is again 60 degree, and if we move further then it is 45 degree. Okay, so the inclinometer use inclination angle. Now question time. Which of the following is not equals to cot square a? And your time starts now. The class, your time is getting over. Okay, so finally time is over. So what is our correct answer? Yes, it is sin square upon cos square a, because we know that tan theta is equals to sin upon cos. So it is equals to tan square a, not cot square a. So correct answer is B. Okay students, now it's last question and this is feedback question and your time starts now. So how do you rate today's class? Okay class, now it's time over. Okay, now see what did we learn today. We learned about the uses of trigonometry in our daily life. So we can measure height of any tower by using trigonometry. So this is called height, this is called distance, and this is our hypotenuse. Okay, and we also recall the values of trigonometric ratios: sine, cos, tan, cot. What are the inverse of sine, cos? What are the values of sine 30? Okay, what is the value of sine 30? Can you tell me? Yes, it is 1 by 2. Tan 45 is 1. Cos 45 is 1 by root 2. So you all should learn all these values. Okay, so I hope you will learn all the value and all the formulas of trigonometry. Okay, so now it's time to end the class, and in next class we will solve some problems by using these values, by using the values of the angles, okay, and by using the ratios of the ratios of the right angle triangle. Okay, so I think you will be prepared for the next class. Okay students, okay, so now we will meet in next class. Till then, goodbye and thank you.